Hi, my name is Alexander Lumsden and I'm a sculptor and I'm the head of education at Bronze Age London. First of all, thank you to the British Academy and King's College London for organizing this great two-day event. And in this particular video, what we're going to do is we're going to have a look at the ancient use of plaster and its impact on bronze casting. Enjoy. The history of human civilization as tool and object makers happened in three key phases: subtractive, forming, and casting. So, what is bronze casting and what purpose does plaster play within that casting process? Well, to understand the arc of that development, we first need to remember who were these early bronze smiths and casters. Well, they would have been nomadic. Materials would not have been readily available to them until much later, once urbanization took hold, which meant effectively that they would have made use of whatever raw materials and plasters that they could find in their local region. So when speaking then about plasters being an ancient art-making material for sculpture, what is it we mean? Well, probably some clarification is required, as often there's not much specificity given in relationship to the material science and moreover to the processes and application of that material. So, to get some perspective, let's separate out the three key strands of plaster: earth and clay plaster, gypsum plaster, and lime plaster. Number one, earth and clay plaster. First plaster-like materials were most likely earth and clay based. Simple mixtures of clay, sand and straw, and these were air dried. Mastery of clay led to pottery and kiln firing, which in turn created ceramic sculptures, clay molds, and casting cores. Specific to the bronze casting process, however, two earth-based plasters have had a major influence: red clay or crushed brick mixed with gypsum and lime plaster for lost wax investment casting, and kaolin clay processed into molekite in the contemporary lost wax shell casting. Number two, gypsum plaster. The transformation of gypsum mineral into gypsum plaster required further experimentation. By baking and extracting the molecular water content out of gypsum, the calcium sulfate dihydrate turns into a hemihydrate. The material is then processed into gypsum plaster, which reforms as gypsum following the reintroduction of water. Its versatility combined with its Mohs hardness rating of 2 made it into a favored art material. From a sculpture making perspective, it's interesting to note that alabaster is also a compact fine-grained variety of gypsum, which besides carving can be processed into alabaster plaster. Number 3, lime plaster. Limestone found favor as a building and sculpting material early on, as it proved more resistant to water and the exterior. Like gypsum rock, limestone is baked in preparation for its use as a plaster. Unlike gypsum, however, this occurs at a much higher temperature, which required further process innovation. From a sculpting perspective, it's interesting to note that marble and travertine are both part of the calcium carbonate limestone family, which can both be made into plasters, with Roman stucco being the exemplary high-grade casting material, consisting of travertine, lime, and fine white Carrara marble powder, which freed up the sculpting process as an alternative to carved marble. By identifying plaster through these three key areas, we can more easily comprehend how plaster has been in constant development throughout time, but also understand how it's interchanged as a sculpture-making material in its own right, and also in the aid of the lost wax casting process. What physical evidence exists of ancient plaster sculptures, and what part did they play in bronze casting? Although there's plenty of artifacts ranging back to the Mesolithic period and all the way through the Roman Empire, the real unbroken knowledge of working plaster should not be taken for granted in and around the Mediterranean, as effectively it would have come to a halt, and in some area the knowledge would have been lost for centuries following the collapse of the Bronze Age around 1200 BCE. But as one civilization collapsed, others would have prevailed, and even Greece itself would re-emerge, and the working knowledge of bronze and plaster would flourish once more. From then on, what physical evidence exists of ancient plaster sculptures in relationship to bronze casting? Well, we can of course refer back to the anecdotal evidence provided by Pliny the Elder, but other than that, what real physical and concrete evidence do we have to work with? Well, it's a challenge, no? Like considering just the sheer limited number of Roman copies in existence of Greek original bronzes and marbles, like the Baia sculptures and fragments from 100 AD. But the fact that there are just a sheer limited number of Roman original copies, so to speak, it does underline why something as fragile as gypsum plaster would not have made it throughout time from the Greek originals that were made. But be that as it may, there's still some worthwhile conclusions we can draw. But you will have to see things through the bronze founder's eyes. So once you start looking at the bronzes in existence in our museums and collections today, it's really through the bronze founder's eyes you can start to understand how these sculptures would have been made and been aided by the process of plaster casting. And to understand a little bit more of that, we're now going to take a look at plaster molding of an original clay and then eventually doing a molding for the human body. Now that we have a real basic working knowledge of plaster casting, we can now turn towards live casting of the human body. We've already highlighted the limited amount of evidence out there to work with, so therefore we need to turn towards the bronzes in our international collection and basically work methodically backwards to understand the usage of plaster in the aid of the casting of these pieces. Now, the goal of this demonstration is not really to prove or disprove whether the ancient masters would have used such a technique, but rather for you to understand the challenges, but also the opportunities that would have been there. And with that in mind, let's have a look at this next example. Okay, so for this next demonstration, what we're going to do is a live cast of our model here, Jessica's right arm. How we're going to do that is basically do a two-piece mold, basically with a division line running across both sides of the arm to be able to release that arm with ease once the plaster has cured. Unlike obviously more modern materials like alginate that appeared in the late 1800s, you could obviously just make it as one piece and then kind of wiggle out that arm out of the materials with relative ease. Obviously a little bit harder with plaster, so that's why we're doing that two-piece mold. So ideally, when you're working with a model or any larger project, effectively you need to work in teams, ideally somebody mixing plasters, and probably if it's a full body, two individuals working on the body at the same time, back and forth, to make sure that everything is curing at the same time. Since I'm alone working today, the only thing we're going to do to demonstrate that you could do it on a live model is that I'm going to be laying up Jessica's hand in clay to give it a nice separation line, which is a little bit difficult to maintain for a longer period of time. So clay is the only area we're going to use in the hand, which basically any model could have actually held in their hand if they were standing. But as you will see soon, you will get a feel for how that works. So the first thing we're going to do is we're going to be laying up Jessica's hand here. Okay, so the next stage is for Jessica to take out her arm, and what we're going to do after that is we're going to be applying the grease to the skin to make sure that it's nice and protected. Also, what we're going to do is we're going to be using a string, and we're going to be putting that up on each side of the arm, basically where the division line will go. As always, if you were doing a full body cast, obviously real attention to where those division lines would happen to make sure to get a good extraction of the cast is of critical importance. The string itself, basically how that would work is rather like a cheese string, you know, cheese cord, where basically once the plaster is in the right consistency, not too hard, but you know, soft enough that you could basically cut through it, you will basically then pull the string and basically make that seam line appear on both sides. So you will see that after this. Right, so quickly working, not too much, not too little, but effectively making sure in particular on the edges, on the elbows, just make sure that that's nice and protected. The key thing is obviously just to get it evenly across all areas. Again, there are obviously preferences in terms of different greases, but again, you use what you have available. But the key thing is obviously that certain greases, they start to melt at a lower temperature than the body at 37 degrees, which effectively means that the plaster could fall off, and we don't want that. So, all right, so let's apply the plaster now. So we got our mixture of plaster here, ready to go. I'm gonna start working that a little bit with my hand. And what we're going to do is we're going to be applying the plaster effectively up to here on the hand. We can do that first without having any impact on the rest of the arm, where basically we're going to lay up the division line. Okay, so last stage, which is now working the inside of the hand. We're going to make sure that there's plenty of grease here to make sure and we've obviously greased the plaster as well to make sure that it comes off. What I'm doing is just making sure that there's nothing basically going underneath the fingers and grabbing it to miss any details. So we're trying to get a good registration is what we're going for here. Is the model feeling okay? You okay? Okay, let's do this. Okay, we're gonna set the plaster. Again, for speed, I've used warm water, or warmish. Also give the model a chance to feel good. So let that set a little bit. Are you ready? Then we have our piece mold, and the next stage effectively is for us to take it to the foundry and from there pull the wax, which obviously starts the whole experience of the casting process. So having seen the body casting demonstration, the plaster mold could have taken a few different routes. One is we have the plaster mold and you would have a clay pressed into it to make a positive clay sculpture. The other one is using the plaster mold and then filling it up with wet plaster and making a plaster original, whereby effectively the internal mold would have been a waste mold that you basically pull apart. The third and last one is that you use the plaster mold for wax reproduction for the lost wax casting process. And on that note, welcome to Bronze Age London, where we're going to explore together how that plaster mold would have been used in the lost wax casting process. So let's do a quick review of the evolution of the different molding techniques that would have been used to understand how, and more importantly, why we've ended up with the mold that we have. The history of bronze casting is not a neat step-by-step process, and the transition from copper smelting to bronze casting would have taken thousands of years, with early examples of any large-scale bronzes having been flat sheets of bronze that would have been hammered into shape and then held together with interlocking keys and rivets. Now, thinking about that and the development of bronze casting, the major breakthrough that happened there was going from solid casting to hollow casting, which effectively allowed you to scale up. And that going forward is effectively what we refer to as the hollow lost wax casting process that would have been employed from the late archaic period and onwards. Now, of course, all that was underpinned by the development of different plasters and the mastery of their application. Effectively, there would have been two main methods that the ancient would have employed when making these bronzes. One being the hollow direct lost wax casting process, and the other one being the hollow indirect lost wax casting process. The hollow direct casting process is effectively that you make a clay core, which is a rough outline of your sculpture, which then gets skinned with wax and then gets sculpted back to basically make the sculpture. So effectively what you have is a unique piece that basically there's no mold to. It is the original artwork. There's no reproduction made. So how would that work? Well, effectively you get some nice and hot wax and you can dip the core into that. Alternatively, you can make wax sheets that basically when they're nice and hot could be just molded like Rip Your Sea, just pushed onto the clay core. So if we look at this rough outline and do one dip, so that would probably be about a 1/10 of a millimeter, and slowly but surely you will build up the layers, and obviously we're just demonstrating this, but from there what would have happened is you could have then added the wax and you could have started sculpting the details as of interest. Again, if there was a, more accentuated lips or whatever, you can then start working this. But the idea being that the core stays put inside the sculpture. The core is, once it gets shelled up, is held in position through pins that you then drill in through in certain positions just to make sure that the core doesn't move, and the negative cavity after we burnt out the wax basically is left perfectly for a uniform, nice bronze. Again, this is not the main part of the demonstration, but I just want to explain just how quickly you could work up detail. Although the core itself is obviously very rough, you can then start making these suggestions, separations in between different forms. Do the eyes, do the mouth, the chin, but you can see all of a sudden you're getting really nice detail which obviously is what sculpting is all about. However, on technical analysis, the likes of the Riace bronzes, it's confirmed that the clay core was poured into the wax cavity, which effectively confirms that the method that they would have employed would have been the hollow indirect casting process, which plaster mold effectively would have been taken from a static object, or in this case a human model. So let's see how we're now going to be pulling one of these waxes from this plaster mold. Okay. Okay. So I've done the first layer, basically grabbing all the detail from, this is effectively the most important part, the first layer when you put it into wax, because the first touch, like plaster before, is obviously what grabs the detail. And the same thing with the wax. That first coat is effectively was grabbing all that beautiful detail that was captured in the plaster, making a positive out of the negative space. We give that a few seconds, and then we go back, and we can do this all in one go, but for the purpose obviously of demonstrating, it's easier for you to see why I'm doing this in stages and what each coat effectively does, which is giving you, well, so we have about a target thickness about 3.74 mil thickness maybe of the bronze. Bronze obviously has a contraction about 2.5 to 5%, depending. So by building this up to maybe 2 mil, then we're going to give it one more slush afterwards, but to unify the different pieces. Okay. Grab a knife. Being molded on a living human model, as you saw in the video before, there's a lot of movement. So a lot of movement, but there is considerable amount of movement that happen if you don't start giving kind of a architectural structure to hold the model in place, which obviously can be done, but you're not going to get really active poses. But with that movement, you're going to have things like crack lines appearing, obviously modern day materials like silicone, alginate, you name it. All those materials obviously have flexibility built into them. Plaster, on the other hand, is obviously structurally completely hard. So minute movement in the crystallization stage of the setting of the plaster effectively is going to have crack lines. How do we fix that? Well, all we would do historically is obviously we can use beeswax. Because it's so cold here today, I actually need to heat it up just to demonstrate. This is microcrystalline wax, a soft wax, a special mixture that is used in contemporary foundries, different to beeswax. Beeswax effectively, structurally, the molecule starts to break down effectively at boiling point, which means that you can't reuse the wax afterwards. Modern day waxes obviously can handle up to hundreds and hundreds of degrees without basically breaking apart. But if you look here, some of these cracks, now arguably another more precise mold maker would have obviously maybe managed to hold that model in place. This I've left purposely in just to demonstrate the difficulty of making a body cast of when we pull that cord, that rope around the model to make the separation line. Remember, this is the roughness of the edge that basically is left. So the neat molds that you do when you lay something up, a static object with clay as we did with a hand, you're obviously going to get a completely more beautiful separation that really will do a nice job for you. Okay, so we plug these holes, most of them. And again, look at this detail. Can you see this? So in the video we said that Jessica was effectively shivering in the beginning because we have a cold mixture went on her skin. So you have goosebumps in there. right? So that's the type of level of detail you're going to get with plaster. Now, effectively, all these are potential issues for chasing and finishing the metal. So arguably could be smoothed out in plaster, or you can fix it in the wax phase. But for the purpose of the demonstration, we're going to not amend the mold, but rather look at what the plaster looks like once we pulled it, okay? This is kind of like a belt and braces approach today, because we're obviously here with the filming team and we want to get this done in the first go. Normally what happens when you make a plaster mold and you're looking at reproductions, unlike making the plaster original. So when you're looking at making a wax pull, the first one generally picks up all the dust, pieces of clay, you name it, whatever the original was made out of, that gets taken out with the first wax. And generally the second wax is a lot better than the first one, as we effectively cleaned it with the first one. I'm going to dry that off. All right. Yeah? You can do this in different ways. You can use a brush, you can do whatever way that you think is the right way. This is just a very quick way to demonstrate how the wax goes in and basically builds up the layers. So we have trimmed everything, all the individual pieces, got a nice thickness to that, and the arm as well. Okay, some of the dust out, good measure. And then what we do is, with a little bit of preparation and a whole lot of luck, this should come together as such. So again, you remember it's a pretty rough line that was made out of the rope, but it still found its registration okay. Although if you look inside, you're still going to see that there's going to be things that we're going to have to fill first with hot wax to get that seam to come together. And after that, we put the hand in and then we slush the entire thing together to make one unified piece. And that's it. Now, remember, as we said, there's going to be quite drastic seam lines on this piece. Since you remember we used the rope to separate the two pieces, and we didn't do any preparation work on this mold for demonstration purposes to show how labor intensive this process really is. If you're going to do it right, you're going to have to spend considerable more hours to make sure that everything is made to perfection. can see how thin that is. Do you see the difference? So it looks to the eye, when you're obviously looking at it from afar, it looks like it's just never-ending thickness of wax, but in reality it's just the overflow in between the light mismatch of the two sides. But easily fixed. Although of course you have to be careful that if the fingers for some reason would appear to be overly thick, then of course it's time to just repull the piece again, which the second time around is a lot quicker, because of course now all parts are working and you know what the mold is all about. Okay, so let's give this another try. In a nutshell, this is what the hollow indirect casting method was all about. It was about being able to make a mold of an object, or a human model in this case, and then be able to again and again reuse that mold for make multiple copies of the same sculpture. And it's impressive what you can do with plaster when you put your mind to it. So based on the technical analysis and measurement taken from different versions of sculptures like the Poximemnos and also the Riace bronzes, I've been asked to demonstrate as well whether or not the use of one mold had been used to replicate the different variants of these sculptures. So hypothetically speaking, what we're talking about is that the sheer labor intensiveness of making these molds would have potentially, as a sculptor or a caster, would have interested you to find ways to maybe multiply the work in different ways. So how did they do it though? Well, first of all, the easiest way to explain it without too much action and brutality to this wax is obviously you don't need to make much alterations to a sculpture if it was actually cast in pieces. Even means that you could alternate different pieces and assemble it later in wax. So an arm that normally would be going straight out like this, obviously you could tilt, bend, something like that and assemble it, and then because you're an able sculptor to start with, you're a master sculptor, you should arguably be able to add a deltoid to that without too much problem or difficulty. But all right, so if that wasn't the case, what could have happened? Well, in this case, we've heated this wax a little bit. I'm not going to do too much drastic actions to it, but let's say where we have the joints meeting is obviously the articulation that happens there is really where that action would happen. Now, why it would have taken a master sculptor to be able to work with this afterwards, which is why I don't believe this method takes anything away from anyone, it still requires that anatomical knowledge and know-how to understand how then the muscles would have followed suit following the contortion of the limb. So, of course, if I just want to do a little bit of an exaggeration of the hand, I can do that like this. Now, again, you see that you're going to have some pushing points happening, but again, being wax is easy enough to fix. And like I say, if you're dealing with master sculptors to begin with, because we got to remember the work was done. The tools and the methods, we've been tool makers since day one. But it doesn't take the fact away that you need artistic genius to be able to pull this together afterwards into one unified looking and convincing piece. So we take out a little bit of wax here, and then you would effectively push that back move that in, put more wax on top, add a little bit of wax on here. The idea that they couldn't have done this, I think, escapes me in a way, because we're talking about master artists. They were always on the lookout, trying to perfect what they were doing. And the sheer evidence that actually the bronzes are there meant that they would have fully well known how to use, obviously, this ceramic cast in terms of making a wax. Now, the question, of course, for the researchers out there is whether or not actually they would have taken these grafts from the human body. But as seen, you know, you get quite beautiful results. Again, when you come into things like the elbow crease, effectively, obviously pushing an arm up is just going to go haywire being waxed, because there's no anatomical bone structure underneath to push against it. So what we'll do is a little bit of nip and tuck. We'll cut a little bit of a mark to come up there. Just give that a little bit of flex. And once we pull it into position, then we sculpt it back. And again, it's not rocket science. It certainly is a lot of labor behind it to learn all these things, of course, as they did. But once they had it in their mind's eye, the anatomy and the references that they followed, and obviously most things would be possible once you master the material. Okay, so, and we go slowly, slowly, slowly. Take out a little bit more. So obviously you're going to get some distortions even on the back, you know, because again, there's no bone there to push against it. But in the end of the day, you take your assistant, you say, show me your elbow, and you start looking at, you know, so, again, you know, a little bit exaggerated that, but, you know, you take that off, smooth that off eventually, find the bone structure and your reference, of course, to rework it. But as far as being able to reshape something is more than possible. Now, if they were successful artists and they had a lot of productions to be handing over to, you know, a team, maybe they didn't want to go through this alteration process, as it might have just been easier to make multiple molds of a body or a clay sculpture, because you knew you were going to be doing several of them potentially. Then you wouldn't have to do this either. But I think it comes to show that even as a, okay, because we got the folds on the inside, we should be able to, you know, again, just follow the logic of the body. When you look at these original sculptures, they don't have texture as such. So the idea that these kind of things couldn't be reworked real quick, because you're not really trying to replicate human skin per se, you're doing something more well, you're working with an aesthetic, aren't you? It's an aesthetic choice that they made. And again, once you then finish this up, you then start to consider what are the next steps. The next stages after this following, of course, is to add the casting architecture to it, the sprues, the pouring channel, the vents, and you will be looking to be putting pins through the wax. So when we then eventually core up the piece, you will basically make sure that the core doesn't move once the lost wax has been melted out of the piece. So that since nice and centered, making sure that the casting is uniform on all levels. But as far as demonstrating, as the saying goes, the only thing that holds us back is our imagination and, you know, a little bit of training. Then in the hands again of a master, anything is possible. And I'm not saying I'm that. I'm just saying that there are people that would have been able, more than capable, of pulling this off in a convincing way. Right. So from then, after we have, made our sculpture in wax, or made a replica of the original in wax, so to speak, it's time to put on the pouring architecture to make sure that actually, we get an even and good cast, because obviously bronze, as is being poured, starts to cool off. And if it's a very big sculpture, you need to find clever ways to make that bronze basically turn up in all the areas at the right time. Now, generally speaking, a good piece of advice is that you do it as a gravity fed, which basically means that what you're trying to do is get the bronze coming down here first to the bottom and then start filling the sculpture from the bottom up, because the pouring cup itself would be inverted like that when we do the actual pouring. And of course, to that we would then be adding things like vents on the back, strut supports, and connectors that basically feed upwards. As the bronze goes all the way down and starts to fill up, then also it will start connect and fill up and make sure that all areas of the sculpture gets fed at the same time. Okay? Okay, so welcome into the ceramic cast section of the foundry. What we do here is obviously that we bring in the waxes once they have the pouring architecture attached to it, and then basically the piece gets invested or gets dipped in ceramic or plaster slurry. Now, looking at the ancient periods, of course, they wouldn't have been using, plaster, gypsum plaster based. They would have been looking at clay plasters effectively that would have been injected into the cavity of the wax. You would have had holes down here to ventilate and get a uniform drying happening. You would have had pins going through to make sure that the core itself dried first and grabbed onto those pins, while then you're adding ceramic or plaster, earth plaster around the piece from the outside. That's then of course gets dried and then gets burnt out, and then we have the lost wax casting effectively. Now, it's fascinating to follow the history of these plasters and how they developed over time. So, of course, today we use things like molekite instead of even gypsum plaster or earth plasters. But again, the interesting thing is, being a ceramic-based slurry that you use, that you effectively can add different types of molekite granules to basically thicken up the layers instead of building up one big investment cube to cast the piece. You can do it in just succinct layers until they have a nice uniform adequate thickness that you can basically use as a pouring cup. But the history of using earthen plaster from the beginning, what makes it so fascinating, and looking at the contemporary way of using this technology, is the molekite itself is made out of kaolinate, which is effectively a mineral which is the major ingredient of Chinese clay. So again, we're looking at clay-based plaster being used, albeit that it has then been dried out and made into a refractory material that then gets dipped. But again, from earth to gypsum plaster molds and all the way to the contemporary usage, we're still using different forms of plasters. And I think that that's fascinating. So we've come to the end, not of this sculpture of course, but as far as this video. The sculpture itself of course would now progress through various stages of finishing, and not to say even the pouring. First starting with the de-wax, which is basically behind me, which is where you invert the entire sculpture, wax sculpture now encased with the ceramic on the outside, or the plaster, and burn out the wax. Followed by the pouring, which is, as you see here, the pouring cups, which is where the bronze, molten bronze, gets cast down. After that, we then fettle, take off the ceramic shell, followed by fettling and chasing, and if you so like, the finishing stage of adding a patina to it if that would have been required. Obviously the Greeks often preferred the bronzes to be left in the raw, in terms of the raw bronze color. But that, my friends, is a different story that will follow in a different movie. So I hope you found that useful and interesting. Next time you're in London, why don't you drop us a line and come and see us? And of course, thank you ever so much to King's College London and the British Academy for organizing this 2-day seminar.